Hi, this is Mr. Hilko. In this video, I'm going to take you through the first 6 problems on page 58, and then I'll create another video to take you through the next 6 questions, questions 7 through 12, on page 59. Okay. These 2 pages revolve around the first 2 topics discussed in Unit 7, Coordinate Geometry, where we, right here, worked on the equation of a circle written in standard form, and then the second lesson, which involved completing the square. So we'll go through that process in a few questions. Just reading the directions here. Answer the following circle questions to discover why 2 Englishmen admitted to perpetrating the crop circle hoax. And in the next paragraph, you can read a little bit about what the crop circle hoax was, but by answering these questions, we should be able to fill in these blanks and have an answer to that question. Okay, so we'll begin with question 1. Before we begin with that, I wanted to show you this. This is the standard form for the equation of a circle. Okay. Remember that the coordinate HK would represent the center of the circle and R would represent your radius. Okay, so we'll be continually referring to the standard form of the circle throughout a few of these problems. Okay. Going over to the actual worksheet here. Let me slide up. I'm actually using a document camera that I picked up from Mahonison High School this morning, so I'm just getting used to working with it, and we'll see how it works. Number 1. Which of the following is the equation of a circle with a center at -1, 3 and a radius of 4? Okay, so using the standard form of a circle equation, we will just be plugging that information in. So how I usually write this is my binomial bubble square with a plus sign between them and the equal sign, and then I just fill in the missing parts. Okay, so it's going to be x minus the x coordinate of your center, which is -1. So it'd be x minus a -1, which we know is just a positive 1, and then y minus the y coordinate, which is a 3, and then you would take your radius and square it. Your radius is 4, so 4 squared is 16, meaning the answer to question 1 would be letter H. Okay. Question number 2. If the point 1, 2 lies on the circle whose equation is the quantity x minus 2 squared plus the quantity y plus 1 squared equals question mark, then the missing value is. Okay. So this missing piece would be the radius squared. So the first thing we would need to find out is what the radius of the circle would be. Okay. Now we know based off of the left side of this equation that the center of the circle would be the point 2, -1. Okay. We also know that a point that lies on the circle would be 1, 2. So to find the radius, we would find the distance between those 2 points. Now the distance formula, I'm actually going to do the work for this problem on a separate sheet. So the distance formula would be square root the quantity x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay. Now the points that we're trying to find, the coordinates that we're working with, are the center of the circle, which was at 2, -1, and a point on the circle, which was 1, 2. This would be x sub 1, y sub 1, x sub 2, y sub 2, and you would plug the coordinates into the distance formula. So you'd end up with 1 minus 2 in your first set of parentheses and 2 minus a negative 1, which in reality is 2 plus 1. Okay? You could put the radicand into your calculator, which is what the expression beneath the square root symbol. But this one you might be able to do in your head. You know 1 minus 2 is a negative 1. Negative 1 times itself would be 1. Here you have 3, and 3 squared would be 9. So the 1 and the 9 give you radical 10. Okay. Now that represents the radius. So we know the radius of our circle is radical 10. But if you go over to the problem, you know that this position represents the radius squared. So what we're actually going to have to do is now take that radical 10 and square it, but that comes out to be 10 because the square root and squaring a value those are inverse operations. So the answer to choice number 2 would be R. Moving right along here, question number 3. A flattened crop circle has a diameter of 300 feet. If the circle is represented graphically with the center located at the coordinates 3, 4, which equation represents the boundary of the crop circle? Okay, so when using the standard form of a circle, there's always two key things. Can you identify the center? Can you identify the radius? Okay, so the center was given to be 3, 4, and it also tells us the diameter of the circle is 300 feet. Well, instead of considering the diameter, the radius would be more valuable, so I'm going to cut the diameter in half, and I know the radius would be 150 feet. Okay. Now that we have those two pieces of information, which is always the two key pieces to get, if you can get the center of the radius, then you plug that information into the standard form. So the standard form of a circle, I'm just going to write, and plugging that information in, it's going to be x minus the x coordinate, which is 3, and then y minus the y coordinate, which is 4. Remember, both of those binomials are squared. And then you're also going to square the radius. So if you take 150 and square it, 150 raised to the second power, it would be 22,500, which corresponds with choice number, or choice letter, I should say, I. Okay, so those are the answers to the first 3. Once we get to number 4, let me move over to a separate sheet of paper because we're going to need a little more workspace. So this is question number 4, and what this question says is that the equation, and let me write that, x squared plus y squared minus 2x plus 6y plus 3 equals 0. Is equivalent to, and all your options are a circle, are circles written in standard form. Okay, so we're going to have to complete the square on this equation in order to get them in the correct form. Okay, so the completing the square process goes like this. The first thing you want to do is organize your x terms together. So I have an x squared and a minus 2x. X squared minus 2x, and if you have both the squared term and the linear term, the x squared term and the x term, you would open up a box. Okay. Next comes your y terms. Okay, so I have y squared plus 6y, and I have the squared term and the linear term, both those y terms, so I'm going to open up another box. Equals. Any term that doesn't involve a variable goes over to the right side of the equation, the other side of the equal sign. So if I have to move a positive 3 over to the other side of the equal sign, it becomes its opposite, minus 3. Okay? Now, however many boxes I opened up on the left side, I also want to open up on the right side. So 2 boxes were opened up on the left, 2 boxes were opened up on the right. Now I'm going to go through the completing the square process. To complete the square, you're going to take the coefficient of the x term And you're going to cut it in half and multiply it by itself. So if I take -2 and cut it in half, I have -1. And then if I multiply -1 times itself, another way of saying as you square the -1, -1 times -1 is +1. Since you're squaring the numbers that go in the boxes are always going to be positive numbers. So if you put a 1 there, you also put a 1 in the first box on the right side of the equation to preserve the balance. Then next, you're going to do the same thing with the coefficient of y, cut it in half to get 3, multiply it by itself to get 9. These boxes are both 9s. Okay? Then I'm going to draw 2 binomial bubbles with squares and a plus sign between them, and then I'm just going to combine the terms on the right side, and that comes out to be 7. Okay? Now what we did here is we created a perfect square trinomial. Okay, so we're going to factor it. And this is the intermediate step that I'll show you that you don't necessarily have to show. If you factored this quadratic equation, pretend it was a quadratic, you use the QT approach. Okay, so you double bubble, factors of 1 that add to 2 are both 1s, and you create a -2. You get two copies of x minus 1. Same thing here, all right? Since it's a perfect square trinomial, if you factor it, you'd get 2 binomials that are copies of themselves, and you'll see why in a second. 2 factors of 9 that add to 6, they're both 3s, and to create +6, they're both positive. So we actually can skip that step since we know that the binomials are going to be copies of themselves, and we could say factors of 1 that add to 2 are 1s, and since the signs are different, it's going to be minus. All right. Here, factors of 9 that add to 6 would be 3, and since we're creating +6 and the signs are both positive, it'd be positive. Okay. Now, if you look what we have the equation for the standard form of a circle that is centered at the opposite of -1 is 1, the opposite of +3 is -3, and the radius would be the square root of this value, which is square root of 7. Okay, but I don't even know if it asks us that in this problem. Let's go back to the problem. It said the equation is equivalent to, okay, and we're going back to this step. That's the standard form of a circle. So the correct answer was, let me just make sure here, it looked like it was letter M. Okay, we're going to continue on, plugging right along, and do question number 5. 5 says the center and radius respectively of the circle x squared plus y squared plus 6x minus 2y minus 15 equals 0 are. So in this one, it's very similar to number 4, except it does ask us to pull out the center and the radius. So we're going to go through that completing the square process again in question number 5. So let me first start by writing the original equation, plus, so you can see it, minus 2y minus 15 equals 0. Okay, so first thing you want to do, move your x terms together. X squared plus 6x, since I have both of them, I'd open up a box. Get your y terms together. Y squared minus 2y, since I have both of them, open up a box. Equals, any term that doesn't have a variable moves to the right side, so the minus 15 moves the other side and becomes a positive 15. Since I opened up 2 boxes on the left, I opened 2 boxes on the right side of the equation, and I go through the completing the square process. So I am going to take the coefficient of x, cut it in half, and multiply it by itself. Half of 6 is 3. 3 times itself is 9. Put a 9 in each first box. I'm going to do the same thing with the coefficient of y. Cut it in half. I have -1. Multiply it by itself. -1 times -1 is a positive 1. Okay? From there, you should be able to write the standard form of the circle. And the reason being, just to set it up, you have your binomial bubble squared with a plus sign between them equals, and whatever's on the right side would be your radius squared. So if you take these three numbers, add them together, you end up with 10 plus 15, 25. Here, factors of 9 that add to 6, 3's. Since the signs are both positive, it'd be a positive. Over here, factors of 1 that add to 2 are 1's, 1 and 1. Since the signs are different, it would be negative. Okay, now from that, we can pull out the center and the radius. The center would be the coordinate. Opposite of positive 3 is negative 3. Opposite of negative 1 is positive 1. And the radius would be the square root of that term. Square root of 25 is 5. So the answer to this one, going back to our original worksheet, should be letter P, which would be a center of negative 3, 1, and a radius of 5. The last one on page 58 and this video will be question number 6. Question number 6 says, which translation, when applied to the center of the circle x squared plus y squared equal 4, creates the congruent circle, which is given by the equation x squared plus y squared plus 8x minus 10y plus 37 equals 0. So we're going to have to do a little more in this problem. So let me first pull out information from that first equation that was given to us. Okay, it said that the translation was applied to the center of a circle who had this equation. Okay, so the key piece of information that we have to pull from that is that equation centers the circle at the origin, the point 0, 0. Okay, the problem says it creates a congruent circle given by this equation. So just by looking at this equation, hopefully you recognize it looks very similar to the equation given in the previous two problems. We have to do a little work getting it in standard form. We have to complete the square. So I'm going to go through that process another time. X squared plus 8x, my x terms together, open up a box. My y terms together, y squared minus 10y, open up a box for completing the square. Positive 37 moves to the other side, becomes a negative 37. 2 boxes were opened on the left, keeping it balanced. 2 boxes need to be opened on the right. Completing the square on the 8. Cut the 8 in half. 4, multiply by itself. 4 times 4 is 16. Put 16 in each box. The negative 10. Negative 10 cut in half is negative 5. Negative 5 times itself is 25. There's my equal sign. Standard form of a circle. When I take negative 37 and add 16 and 25, I end up with 4. Now filling in the binomial bubbles on the left side. Factors of 16 that add to 8, 4 and 4. Since the signs are both positive, the sign in that binomial bubble would be positive. Y. Factors of 25 that add to 10, 5 and 5. Since the signs are opposite, that would be a negative. Okay. Now from that equation, we can pull out the center, which would be negative 4, opposite negative 5, positive 5. Okay. Now looking at both equations, okay, the radius of each one, since the right sides are both 4, would be 2, because the square root of 4 is 2. Okay. The only thing that changed was the center. It went from 0, 0 to negative 4, 5. So what translation would take us from the origin to a center of negative 4, 5? Okay. The translation vector would be left 4, because we're going from 0 to negative 4, left 4, and then to go from 0 to 5, we'd be going up 5. So the translation vector would be negative 4, 5, meaning you move left 4 units and up 5 units, which was letter E on this worksheet. Okay, so hopefully that helped out. thank you for watching the video. If you do have questions, make sure you tune in to Mrs. Ebers, Mr. Maz's, and my office hours or Google Meets, and we'll be able to help you even more. Okay? Enjoy.